lesson, we're going to talk about classifying polynomials. So who can tell me what a polynomial is?
Is it a polygon that can't get a meal?
All right, well then we better start by defining what a polynomial is. A polynomial is terms separated by either addition or subtraction signs. So what we use all the time is a polynomial. Everything we did in warm-up was polynomials. We just didn't call it that. Good. All right, so when we talk about a polynomial should be written in what we call standard form. But you guys already know this too. Standard form can be written in two ways. If there are only variables involved, then we do it by descending exponent. So for example, maybe I have 3x to the third plus 2x squared minus 7x plus 1. You'll notice this is in standard form because my exponents start at the highest one and they go down or descend in order. 3, then 2, then 1, then 0. The second way we do standard form is alphabetical. So if you have a variable or different variables, you want to make sure that you write the terms in alphabetical order. For example, maybe 3a to the third plus 4b minus c. All right, so those are two different ways we're going to write it in standard form. And we talked about this back in Chapter 2 when we worked with the distributive property, right? Okay. Before we can classify, to classify, the polynomial must be in standard form. Which means, to put it in standard form, you're probably going to have to collect like terms. Okay? Do we need to talk about how to collect like terms? No, we don't? Okay. All right, so then let's talk about classifying it. When we classify, we do it by two words. The first word represents the degree. So the degree means the highest exponent. The second word we're going to use to classify the polynomial is number of terms. All right, so I'm going to make this like a little table here, a little chart that's going to help you out when you're doing your homework today. First of all, if you get a polynomial where the highest exponent is a 0, which means there aren't any variables at all, the word for that is constant. And of course, if you have no terms, then obviously that isn't a polynomial. So I can't count that one. If my highest exponent is a 1, such as like 7x, that is called linear. If it only has one term in it, it is called a monomial. If your highest exponent is a 2, the word for a polynomial that's got a squared term in it is called quadratic. If the polynomial has two terms, we call that a binomial. If your highest exponent is a 3, we call that cubic. If you have 3 terms, we call that a trinomial. Okay? If your highest exponent is a 4, the word for 4 is quartic. Like a quarter, there's 4 quarters in a dollar. Quartic. If you have 4 terms in your polynomial, we're just going to say it's a polynomial of 4 terms. So anything greater than 3 just becomes a polynomial of that number of terms. Okay? 5. If you have a highest exponent of 5, the word for that is quintic. Again, if you have 5 terms, it's a polynomial of 5 terms. And if you have anything bigger than 5, so like 6, 7, 8, we just say it's a degree, in this case, 6. And then if it was degree 7, degree 8, that. So we only have special words for 0 through 5. All right, so let me show you how this works. If, and I'm going to write it in standard form to begin with, let's say I have a polynomial that looks like this. I have 3x to the second plus 4x minus 2. My highest exponent, because this is in standard form, my highest exponent is a 2. The word for 2, or degree 2, is quadratic. Then the second word is the number of terms. I have 1, 2, 3 terms. So 3 terms is called a trinomial. So this is called a quadratic trinomial.
So for the exponent, it's just what the exponent is?
Yep.
Does this get hard?
Probably.
All right, let's try another one. Let's say I have 7x minus 10. What is the highest exponent we have here? A 1. What is the word for a 1? Linear. Good. And there are 1, 2 terms here, so it is a binomial. Yep. So you would call this a linear binomial. All right, how about if I have 3x plus 9x to the third minus 7x. Before I can classify this, what do I have to do to it?
Collect like terms.
Got to collect like terms and put it in standard form, right? So when we start to do that and put it in standard form, start with your highest degree. What term up there has the highest exponent on it? The 9x to the third, right? So we're going to start by writing that down. Are there any other x to the third? So I have 9x to the third to begin with. So that term's done. Do I have any x squared? Okay, but I do have 3x and negative 7x. If I collect those together, how many x's do I have? I heard somebody say it, negative 4x. Very good. So now we can classify it. The highest exponent is a 3. What's the word for that? Cubic. Very good. It's cubic, and it's 1, 2 terms, so this is a binomial. Exactly. All right. Any questions so far? Okay, I'm kind of giving you, before we actually get into examples and stuff, I want to get the whole backstory and everything, and we've got to make sure we understand everything. Okay, so I have to add one more thing. So now, we've talked about all these different terms, how we're classifying stuff. We do, of course, everything in math has a special case, right? So I want to talk about special monomial cases. A monomial is one term. So it's a special case when that monomial has more than one variable. All right, for example, let's say I had 10a to the third b squared. This is a monomial because it's only one term. But to classify this, because it's got more than one variable on it, this is the only time we do this, we add the exponents. So to classify this one, we would add our exponents together, which would be a fifth degree. And what is the word for a fifth degree? Quintic. Very good. Quintic. So this would be a quintic monomial. All right? That's that special case if you have more than one variable in that term. All right, so we're going to start with example number 1. Example number 1, that is your 8 through 14. Find the degree of the monomial. So some of them are going to be really easy. Some of them might be a little tougher and be special cases. So maybe we have 7y. This is a monomial. But what is the highest exponent here? It is a 1. And what is that word for 1? So this is a linear monomial. What if I just said 12? Well, do I have any variables? So if you look on our little table, so there's a 0 exponent technically, and so this would be a constant monomial. And let's say we got, negative 3x squared y squared. So now we have 2 different variables. Takes us to our special case. What should we do to decide the degree of this monomial? Good. If I add the exponents together, I get a 4th degree. And what is the word for a 4th degree? Good. Quartic. So this is a quartic monomial. Any questions?
I have a question.
Uh-huh.
It keeps making me think of like fast food, how you like a this meal, da-da-da-da-da.
Okay. All right. All right, example number 2. All right. In the next one, I'm going to ask that you simplify and classify. All right, this is going to be our 16 through 28. So let's say I have, we'll start off with an easy one. How about 12p squared minus 10p squared plus 7p? So first thing you have to do is simplify it and get it into standard form. To simplify that, that means you have to make sure that you've collected all like terms and that your exponents are in descending order, right? Okay, so my highest exponent up there is a 2. I have 12p squared, and I have negative 10p squared. We have 2p squared. Very good. That takes care of those terms. And then I have this plus 7p. This is in standard form. Now I got to classify it. Our highest exponent's a 2. What's the word for that? Good, quadratic. And there are 2 terms. What's the word for 2 terms? Binomial. Very good. All right, let's try another one in the same example. I'm just going to kind of draw a little squiggly line across. Try another one where I want you to simplify it, then classify it. What if we had 8 minus 12 x to the third y plus 2 x to the third y. Anybody got any ideas? First of all, they all have the same label on them, right? They are all x to the third y's, correct? So we're going to add all of our coefficients together because they all have the same label. So I have 8 x to the third y's minus 12, give me negative 4, plus 2. So negative 2 x to the third y's. All right, so now let's classify it. You're close. No, it's a monomial, I agree. You're close. What exponent's on this y, you guys? It's a 1. Thank you, Keegs. It's a 1. So what do we have to do since there's two variables here? So to classify this one, it becomes a quartic monomial. So don't let that one trick you. Any questions so far? We're all good? All right, so then I have two more things to talk about, and I'm done. First thing I want to talk about is adding polynomials. When you add polynomials, first step, I want you to drop the parentheses. Step 2, collect like terms. All right, so this is example number 3. And this is going to be 30 through 34. All right, so maybe it looks something like this. 2x to the third plus 7x plus 3x to the third minus 5x. So it's a polynomial plus another polynomial. So step 1, since it's addition in the middle, we are adding them. We drop the parentheses. So these are going to be gone. So I'm going to rewrite this as 2x to the third plus 7x plus 3x to the third minus 5x. So when you write it down on your paper, you can automatically drop those parentheses, right? Now we're going to collect like terms. What two terms do you want to start with collecting first? And? Good. And that'll give me how many x to the third, Madison?
5x.
Good. 5x to the third. I agree. That takes care of those. All right? That means then I've got to collect together my 7x and negative 5x for a total of 2x. And that's it. Okay, now, remember that our books are a little old. They wrote a couple, see how I wrote this one horizontally, like next to each other? They wrote a couple of them vertically. So I just want to show you what that looks like. Make sure we talk about it for a second. Okay, so they wrote it like this. Maybe they have 3x minus 7 plus a parenthesis 2x minus 4. Like that. So when you write it down, how do you think I want you to write it? Yes, horizontally without the parentheses, right? So this becomes 3x minus 7 plus 2x minus 4. Collecting like terms. I have a 3x and a 2x.
When you said vertically, I thought, like, you know those signs with like the line, the letters going down? That's what I thought.
Oh, yeah, nope, this is vertically. Okay, collecting our 3x and our 2x together, I get 5x. And then negative 7 and negative 4 is negative 11. Very good, you guys. Do we have any questions on adding these together? No questions at all? All right, well, if we added, what else do you think we probably should do? It is a linear binomial, but let's also do some subtraction. What do you think? All right, let's talk about subtracting. polynomials. All right, so here's the steps when we subtract polynomials. Step 1, drop first parenthesis. Step 2, distribute a -1 through the second parenthesis. And then step 3, collect like terms. All right, so I'm on example 5, right? I'm only on 4?
Yep, one on four.
All right, 4 it is. Example number 4 is going to cover your 36 through 40. All right, so maybe you have something that looks like this. 2x to the third plus 7x squared minus 5x to the second minus 2x plus 1. So I have a polynomial minus another polynomial. All right, so we're going to start by dropping the first parenthesis. So I have 2x to the third plus 7x squared. Step 2 is I'm going to distribute a -1 through my second parenthesis. -1 times 5x squared is -5x squared. -1 times -2x is positive 2x. And -1 times 1 is -1. I'm to the end of the parenthesis. I'm done distributing. So now step 3, collect like terms. What do we want to start with?
7x squared minus 5.
Okay, so remember we want to write it in standard form. I agree you got to collect those two together, but what should we write down first? We want to write down our highest exponent one first, right? Which is this 2x to the third. So I'm going to put 2x to the third as my first one. So now that one's done. I've got that already. Now I'm going to go to x to the second. I have a 7x squared minus 5x squared for a total of 2x squared. Exactly. So now those are done. Then I go to where I have x to the first. What term has an x to the first on it? Plus 2x. And then minus 1. All right. Well, while this is up here, let's classify it. The highest degree is a 3. What's the word for that? Cubic. Very good. And this is a polynomial of 4 terms. That's how you would classify it. All right. So, again, you got to love this book. I just want to show you they wrote one of these vertically as well. So they might have something like 3x plus 4 minus parentheses 2x plus 10. So when you go to write that down in your paper, you're going to write down 3x plus 4, and then what am I going to do for this bottom half? Remember that this is a -1, and I'm going to go ahead and, so -1 times 2x is -2x, and -1 times 10 is -10. Very good. Now let's go ahead and collect like terms. Start with our x's. We have 3x and -2x for a total of 1x, or just x. And then I have 4 and -10 minus 6. Good. Can we classify that? Yeah. What's my exponent on this x? So the word for first degree is linear, and it is 2 terms, so this is a binomial. This would be a linear binomial. All right, so I'm only to problem 40. The other problems, they are asking you to collect like terms. Okay, that's all the rest are. Do we need to? No, are you sure? Okay. All right. we don't need to, then I'm going to stop right there. You have problems 8 through 50 even to do for tomorrow. Huh? Yeah, and they don't take long, though. All right, you guys, this is work time. Ladies and gentlemen, I'm still recording.